So again, thank you for being here. And very short introduction about myself and Julia. So we do work at Transport, and some of our colleagues are here today. And we are part of a group, new one, is a new research institution which has been very recently launched by a consultancy which is called Systematica, which is a 30 years old consultancy very much focused on transport planning and mobility. And very recently, after a 5 years period of doing research internally and informally, we did decide to open and launch a new entity which is called Fondazione Transport. So it's a foundation, no-profit institution, focused only on research. My name is Andrea. I coordinate the activity of TT, which is the acronym, much easier to pronounce the name of the Fondazione. I am an environmental psychologist with experience in mobility. And here by Julia.
Hi, I'm Julia. Can you hear me? I'm working at Transform Transport since a couple of years, and I'm a geomatics engineer. So I focus on the analysis of geodata mainly, and I will present to you a few of the ongoing projects on this topic.
Okay, so we 3 weeks ago we got in touch with the organizer of the event, and so we start thinking about which project we were going to present, to introduce you today. So let's say the title of the initiative is Together as One. So we decided to focus on the studies we do perform with very different kind of sensor, but everything is related to pedestrian crowd dynamics. So collective phenomenon which occur in the city. Every one of us has experience of a crowd, being part of a crowd. Some of our experiences are good, some bad, but the point is that you can recognize a crowd from let's say from airplane point of view. And what we do perform as a researcher, we try to unveil some hidden patterns, looking at crowd, looking at public space, and to support the design of the city to be more inclusive and more sustainable through mobility studies. And as I mentioned, Systematica, which is the founder of the research unit, is active since the late 80s and started as a spin-off of Politecnico di Milano. Was funded by Professor Fabio Casiroli. And so research was there since the very beginning of the group. And you can see in this slide, let's say many projects we developed as a team. And then this year we decided to open the no-profit research foundation. So in 2017, the research unit was informally launched, and it was firstly focused on some of the more innovative consultancy projects. So sometimes our clients ask us to perform studies which are not like our routine-based, let's say, job as transport planner. So you have to develop some new techniques, new metrics, new studies. And then we came across some European project funded by the European Commission, which is, let's say, high-level research. So you have to recognize standard in producing and disseminating the results of the research. And after a while, also thanks to the COVID period, which enabled us to work a lot on research as an emergency period, we decided to collect all the results of the research produced during the last 2 years and to open a new entity. And so the results of our research are disseminated through different initiatives and tools. And this slide, you can see some of the books we do produce yearly. So at least one book every year. And the very last one, Shifting Paradigm, is focused on the studies I mentioned. So the investigation of the impact of COVID-19 on urban mobility. And the first edition of the book was released in the last year. And in September, we are going to release I hope the final edition, and about the second also. And I want to somehow to introduce you why do we talk about urban informatics. So we are targeting the sustainable development goals defined by the United Nations. So we do believe in contributing in a more sustainable urban environment. And these SUMP, for those who are experienced, let's say, in urban studies, are the plans that cities and municipalities develop to plan mobility in, targeting a 10, 20 years horizon. So what we do is to to contribute to support the definition of these plans through innovative metrics. All the results, let's say, are focused on sustainability, above all focusing on, for example, walkability and pedestrian dynamics. And during the last year, during the pandemic, it was clear, for everyone that our city are not so sustainable, not so accessible, and the framework of the 15-minute city became, let's say, a kind of a claim, which is very easily understood by everyone. So we need city. You can walk in comfort and in safety, and you can easily access services, essential services within a 15-minute city distance. And this slide summarizes the approach. So on the left side, urban informatics. We do combine urban planning, traffic engineers, social sciences, but ICT technology as the first actor of the data we collect and analyze to support the definition of innovative metrics. And on the right side, the four main topics we are targeting through transport. So again, mobility metrics, livable street, innovative technology, and transport infrastructure. We do work at different scales, from the urban scale, macroscopic, to the microscopic intervention, and today we're going to show you some example of intervention and, let's say, the application of these two to make the city more accessible and sustainable. This is the way we summarize, let's say, all the theme of research we are targeting, the topics, subtopics, let's say, and all of them could be classified by four main SDG related to sustainability, gender inclusion, and some other. These are the partners and collaborators we already collaborate with. Some of them are universities, mostly Italian, but also foreigner, university abroad. But I want to highlight the possibility for us to collaborate also with companies, and that was clear during the COVID pandemic. There is a couple of projects we are going to show you performing in collaboration with two companies that they collect and sell data for a very different purpose, for proximity marketing initiative, which is far away from our, let's say, approach. But we were able to link the two competencies for understanding the impact of COVID in the city. This is one of the example of this kind of collaboration. The company is called Freeluna, and they manage a network of hotspot Wi-Fi in the city of Milan, but also in other cities in Italy. And we collect by them a 7-month period of data. So each hotspot is able to count the mobile devices which, let's say, pass nearby the sensor. And at the end, you have a map of crowding in the city. And this map could be based on the time series of data. So we did perform an analysis from a period which was before the COVID until the end of July. And from data analysis, it was clear that this kind of data could enable us to understand the impact of the restriction policies and measures, let's say, prescribed by the municipality. This is another company called Blimp AI, and they develop a sensor which is, with an AI incorporated into the sensor. So the technology is able to count through the sensor disaggregated data. So pedestrian flows, traffic flows, bicycles. And the point was to understand the impact of COVID again for a different period of time, but also to correlate data with the city, the characteristics of the city. So we call dynamic data, the one from the sensor, but to be correlated with time invariant data, which are the land use, the presence and density of point of interest, public transport services, demographics of the inhabitants. And so we start also using some innovative statistics called spatial autocorrelation. So the data which are located in the same region do autocorrelate in between each other, so you need to limit, let's say, this kind of statistics. And then there is another research developed by Julia.
Yes, so parallelly to collaborating with companies, we decided to gather, collect, and analyze open data that were available within the cities in order to gain a broader understanding of possibilities that could be explored through different data. So the project, which is shown in this slide, aimed at understanding deep learning analytics techniques on images, and the project focuses on Corso Buenos Aires mainly. There is an open camera taking pictures of the street every hour. So we collected images for 1 year long, and we detected through deep learning techniques vehicles and pedestrians and different classes of objects that are present in the street in order to understand the patterns and the evolution of the pandemics in the footfall of the street. So on the left of the slide, you can see the graph showing different open source methodologies to gather and analyze data. And on the right part of the slide, you can see a few snapshots of the detected object with semantic segmentation techniques. So the next. Another study that we performed was semantic study of Twitter posts throughout the pandemics. In particular, we decided to analyze tweets that were sent or posted nearby stations within the different pandemic periods. And we decided to analyze through automatic text comprehension technique the different words that were analyzed, that were written down in tweets throughout the COVID pandemic. You can see a huge number of, let's say, tweets that were posted using the COVID lockdown prevention classified words in the lockdown phase with and the different trends throughout the following months. And this gave us an idea of the perception of the pandemic through text and the social media. And another study performed within transport was about car sharing data. So the analysis of temporal patterns and the use of this type of mobility in different moments of the day, and the substitution and complementarity patterns with different means of transportation. So peaks of use in the evening times, but also the correlation of this kind of mobility patterns, again with time invariant land uses and services within the city. So the map shows different moments of the day and different densities in the use of this type of mobility.
Yeah, I recognize the screen is not so clear because of the sunlight, but I mean, we can share easily the PowerPoint or the PDF, so it's like very possible to see. And let's say the first pillar of the approach we do follow for performing research is urban informatics. The second one is a user-centric approach. So now I'm going to show you some ongoing and already executed research project focused on specific target users of the city. So first, elderly, one of the most vulnerable road user in terms of accident, but also, let's say, a psychological sense of vulnerability in the sense that they don't feel like free to move around the city because of, I'd say, mobility limitations. So this project was performed in collaboration with Varup and other partners. Is a book which is focused on a sample of relevant large city in the EU region. And let's say a series of GIS analysis were aimed to assess the level of walkability for the elderly in this sample of cities. Another example is a project which was part of a competition held by Comune di Milano, which is called Piazze Aperte. Is a tactical urbanism initiative very much in line with and promoted by the Bloomberg Association and NACTO. So what they did in the late 2019 was to propose to the citizen a possibility to intervene and propose project for the regeneration of 50 new squares and we did participate for 2 proposals. And if you have, let's say, time to walk around the city in this week, this square is nearby the venue. It's called Piazza Minniti. So the project was positively, let's say, received positive feedback, but then was incorporated into another initiative called Open Street, which was let's say, the way the municipality tried to answer to the COVID pandemic. And another, let's say, typology, let's say, profile of target user are women. And this is an example of an H2020 project called Diamond, which recently ended in January this year. And we were a part of the team focusing on GIS and data analytics for 2 of the 4 use cases. So women as users of railway system and women as users of bike sharing system. And we did perform analysis related to the cities of Paris, Barcelona, and Warsaw. Another example is the analysis we did conduct for estimating the width of sidewalk of the city of Milan during the first period of the pandemic. So we are, let's say, looking back in time, it was like April or March, so the proper lockdown period in 2020. And the goal of the research was to estimate, the need of a new temporary infrastructure for pedestrians for allowing us to walk safely because of social distancing. And then some let's say, related research related to the focus as well to the 15-minute city framework. So this is focused on the city of Milan, but we did perform some similar analysis to the city of Bologna. So we did map the 15-minute city for children in Bologna. And again, we did use GIS to evaluate the level of walkability for women in the city of New York. We Semantic recently opened a new office, subsidiary office in New York. So we start also performing research focused on that city to potentially support the municipality for a new project, a new intervention. And we did also collaborate with Accurate, which is a database company based in Milan, for developing a mock-up of an app related to the 15-minute city framework. So the app allowed the citizen and the user of the app to visualize the location of the essential services nearby, for example, the address of his or her home, but also to input information in the data if some, let's say, some services are not mapped by the municipality. And again, related to COVID, we recently attended the TRB conference, which is the largest one in Washington, D.C. This year was the 101st edition of the conference and is related to traffic engineering. So we calibrate the social force model, which is behind a simulation tool called VSWalk, to simulate pedestrian dynamics through the lens of social distancing. And another example, last one, a collaboration with Land, which is a landscape architecture firm in Milan. We are now collaborating with them, combining 2 different data sets. So a traffic model, estimating the volumes of traffic volumes and flow, and also the emission related to vehicular traffic in Milan, with another data set which comes from the city, from the geoportal of Milan, which is the census of trees. So the presence and density of each kind of species in the city of Milan. And the idea behind the research is to understand for both of us, TT and Len, how to manage urban planning projects to use nature-based solutions to mitigate the effects of vehicular traffic. And so now we can focus on, let's say...
Yes. Yes, so I will focus on the pedestrian flow analysis, and I wanted to start with this image, which shows Piazza Duomo in Milano, so an iconic public space, which was analyzed again with deep learning analytics, which are the main focus of this next part of the presentation. And in particular, our focus here was to detect pedestrians and to detect the patterns that pedestrians create within a public space, which is as broad as Piazza Duomo, for example. The idea here was to first detect pedestrians and then being able not only to have the perspective view of the square, but also to develop a methodology to map the pedestrian activity on geographic coordinates in order to analyze densities and patterns within the square. So this work will be presented as well at the Space Syntax Symposium, as it is the base of a further analysis on space syntax metrics and tools and how they correlate with the pedestrian footfall. And the last image shows the results of this analysis on Piazza Duomo and how the patterns that could be seen, let's say, on the video were then gathered in just a snapshot of the flows of the pedestrians within the square. So a few parts of the square really show up, for example, the metro exit and these diagonal patterns within the square. So it's just a way to tell how we perform this kind of analysis, what is the methodology, and what is the final result that we expect. So this same methodology was then proposed in different studies in order not only to study the technique, so the deep learning techniques on videos and images, but also to have different kind of results, for example, in climate comfort and walkability studies. So the goal here was again to study the images of Corso Buenos Aires that I presented in a previous slide, again for different periods of time in order to have an overview of how these images and how these data could be gathered and if it showed patterns that were expected in different moments of the year, or if they could only tell, let's say, a story of small moments within a day. So the graph here shows different weekly and hourly patterns for different months of the year in 2019. You can see weekday and weekend patterns, and you can see, let's say, some flows of this methodology by seeing how peaks can be really high, and this can be due to events in the street. So images, of course, show just a snapshot of a street, but also how gathering a lot of data and having the consistencies of a lot of data can enable us to detect patterns in a broad way. This slide here shows the same kind of data analyzed for a longer period of time. So from September, or actually January 2019 until May 2021. Here again, the COVID pandemic was used as a base to detect patterns in different moments of the pandemic. And on the top of the slide, you can see weekly patterns in pre-pandemic lockdown and necessity and soft restriction phases. You can see the detected footfall and how it changed throughout the different moments of the pandemic and the evolution of the pandemic. And this is even clearer in the bottom part of this slide, where not only weekly patterns but hourly patterns were gathered and detected throughout the different moments of time. So on the very left part of the slide, you can see hourly patterns from 6 a.m. to 10 p.m. in the pre-COVID pandemic, then the lockdown phase and how the very little footfall was detected in the street, and then the evolution of the different phases with a focus on the necessity to phase and so on, where lockdown, let's say, curfew moments were put in place in Milano at 10 o'clock. So the footfall really decreased at that time of the day for in this Corso Buenos Aires. And again, this is a snapshot of Corso Buenos Aires in a summer day, where you can see different moments of the day from 12 a.m. to 5 p.m. So Corso Buenos Aires is one of the, let's say, longest retail streets in Europe, and it has a peculiarity. So it's directed north to south, which means that in the middle of the day, the shadow suddenly goes from one sidewalk to the other. And this is clear in the images. So from, let's say, after 2 p.m., so from 3 p.m., the shadow is on one sidewalk, and before it's on the other one. So we wanted to investigate how shadow in the street would affect the detected footfall, or if there was some patterns that could be linked to shadowing and temperature in the street. And this graph here summarizes the study, showing in the black lines the different mean temperature for different months of the year in 2019, and the percentage of sidewalk queues, so the distribution of pedestrians in the two sidewalk within the month. So a preference for the left sidewalk, which is shown in the red curve, is clear for most of the months, other than the summer months where temperature reach 30 degrees and above, and the moment where the shadow changes from one sidewalk to the other corresponds exactly to the moment where an abrupt change in pedestrian mean footfall is registered in the street. So this is, let's say, interesting output, which started as an exercise for Corso Buenos Aires and can give us, let's say, the opportunity to think about climate comfort and doing, let's say, research on the use and the design of streets where climate is of high importance, where it's fundamental to design for climate comfort in the street. Then we use the same technology for assessment of a tactical urbanism intervention. And in particular, we focused on the study of a public space in Bologna, which used to be a parking space and then became a street and a square for kids. You can see in the image on the left the design of this square and how let's say there is a street crossing this square and the furniture and design that was proposed for the square. So in this area, we mounted a camera and we recorded the area for 1 month before the intervention. So the parking space dynamics, let's say, and then we recorded 1 month of patterns after the intervention. So our goal here was to understand the changes in the use of the street and of the square, and if the design of the square brought to improvements or some patterns that could not be expected. So in the bottom of the slide, you can see the timeline. Before reaching this phase, we did a broader study on Bologna and on the services, land use, and patterns, and also on with space syntax in the neighborhood of this square, in order to reach to the let's say definition of the square. And our goal, as you can see on the top right of the slide, are detecting post-occupancy evaluation of the public space, so behavioral maps, desire lines, cumulative density, but also study the different patterns in the subjects that use the square, so vehicles and pedestrian, and how they interact with each other before and after the intervention. So I will show you now a few examples of this analysis. We are interested in understanding how pedestrian flows changed and what are the walking patterns and crossing behaviors before and after the intervention. So this slide here shows just pedestrians, and the next slide shows another topic of study, which are not only pedestrian flows and crossing behavior, but also pedestrian densities post-intervention. So we decided to study 3 moments of the day, the morning from 7 to 9, afternoon from 1 to 3 and evening from 5 to 7. These should show different patterns, for example, when kids get into the school or go out, or the average use of this public space. So we want to also understand the different footfall and peaks in the use of the square at different moments of the day. And then we analyzed the speeds and velocities of pedestrians and how they are how they are using actually the square. So in blue you see the higher velocities, and in red the lower ones, showing different, let's say, resting spaces in the post-intervention moments, but also showing crossing patterns again within the street and the square. The other subject of the analysis and study was vehicular flows. We do not expect vehicular flows to change much, but we focus on these mean of transportation as it's, let's say, fundamental for studying the interaction with the pedestrian. And again, we study the speed of vehicles within the square, how they will change and how they have changed before and after the intervention. And this is, let's say, a final slide showing an image before the intervention and after the intervention. And on the right, our next focus for this analysis, which is, again, the interaction of vehicles and pedestrians. So you can see in yellow vehicles and in blue pedestrians, and these are cumulated flows in 1 minute, which means that when the two different flows cross, there has been some kind of interaction between the different subjects. So our goal is to analyze what is the behavior of pedestrian crossing the street, what is the behavior of vehicles, and how they, if they are compliant with driving rules and safety rules, but also to understand if the layout of the square improved safety, and if studying the square before the intervention and analyzing patterns that could be seen before the intervention would really help us predict the new behaviors in the use of this new public space. So I leave you with this open question, and thank you very much for joining us. You can make some questions now or at the aperitivo socializing event, and you can reach us at the email shown here in the slide. Thank you.
Thank you. Good question. I mean, I could try to reply saying that the entire pandemic period was kind of an experiment for everyone, also for municipalities. It was an accelerator of, let's say, plans and projects, ideas which were already there. So some of the results are confirmative somehow towards a more sustainable environment. The use of AI for collecting data, given the GDPR, was already there before the pandemic. But the citizens were kind of skeptical about the use of AI and sensors because of privacy, which is right. And I think thanks to the pandemic, everything, I mean, the use of AI was more acceptable for the public, the general public. So for us, I mean, our daily job is to find data. I mean, being respectful for policy and regulation. Everything, I mean, every project showed today is GDPR compliant. But thanks to the pandemic, I think the takeout is that it's possible to collaborate with citizens actively or passively involved in collecting data through ICT technology.
Yes, thank you. Thank you for the question. In the Twitter example, we didn't only study the semantic of the tweets, but also how they were geolocalized, and we specifically selected tweets that were sent nearby stations and tried to analyze if the tone of the tweet would be in line with different disruptions in the network. And so we used tweets also in, let's say, the geographical sense, but we didn't use other social media data for this research, which would be for sure interest. And to answer your question, I think that for me the most interesting thing in analyzing COVID data is that many times, for example, in the Corso Buenos Aires example, when, let's say, an hypothesis was formulated, it was then, we were able to see actually the answer in the data. So the theoretical assumption could be seen in the results, and so I think this for me was sometimes very interesting, because it let us, it was a test bed to see if, since there were huge abruptive change in the use of the street, to see that, let's say, something that you can say theoretically can be then really seen in the data, and this also demonstrates how the data and gathering a lot of data can help us seeing real patterns within the use of the street. So that for me it was like even seeing that what I thought was actually seen in the street was very interesting.